So merit factorizing, but before we look at that, let's revise simple factorizing. So in simple factorizing, if the lowest number of two terms is in common, then we divide it outside the brackets. If an unknown is shared, then we put that outside the brackets. Negatives stay in the position they started, and the factorized result is the opposite of expansion, because factorizing and expanding are opposite. So now on to complicated ones. So sometimes we'll have a common number factor and a common unknown. If that's the case, we must factorize out both. Let's have a look at a few situations. So we have 3x squared plus 9x. Looking at that, we see that 3 and 9 share a common factor, and x squared and x share a common factor, so we factorize out both of those, both the 3 and the x. Here's another one. Look at that. We see 5 and 25 share a common factor of 5. A, B and B have a B in common. We take the 5 and the B out, leaving us with A and 5, because 5 times 5 is 25. Nothing says that the factor coming out has to be a single. We can take more than one of them out as well. So in this case here, we see that ABC and 2AB have both an A and a B in common. We'll take both the A and the B out. In this case, we see that x cubed and x squared not only have an x in common, they actually have a squared in common. So we take both of them out, and we've got x squared on the outside, the remaining x inside the brackets, and the remaining 2 beside it. In more awkward cases, the number doesn't always divide out exactly. So we look at 6x plus 9. Well, 6 is not a factor of 9, doesn't divide out exactly. The highest common factor of the two of them is 3, so we take out the 3. 6 divided by 3 is 2, so 6x turns to 3 lots of 2x. 9 divided by 3 is 3. Here's another case. 40 and 30 share no single common factor higher than 10, so we take out the 10, leaving us 4x, because 10 times 4x is 40, and minus 3, because 10 times minus 3 is minus 30. It's absolutely vital that we take out every common factor, not just the first ones you see. So in a situation like this, we have something that is true. 40x minus 30 is 2 times 20x minus 15, but it's not sufficient, because 2 isn't the highest common factor of 40 and 30. It's correct mathematically, but it won't get the marks because it is not fully factorized. When they say factorize an equation, they mean fully factorized, and we must keep on going until we've got every common factor. So in this case, we have 10 on the outside. Another example, x cubed and 2x squared do share an x in common, so the left hand side of this is equal to the right hand side, but it's not sufficient, because again, it's not fully factorized. There's another x that can be taken out and must be taken out. Occasionally, the highest common factor is one of the terms itself. If that happens, then we leave a 1 behind, not some 0, or try to remove it entirely. So in this case, the 3 is the highest common factor of 3 and 6, and when we divide it out, we leave it behind as a 1, because 3 times 2x is 6x, and 3 times 1 is 3. In this case, the x's are in common. When we divide them out, we are left with 6x from the 6x squared and 1, because x is 1x. None of these rules are specific to 2 terms, they work just as well with 3. So in this case, we look at that and we see that the 3, the 9 and the 12 have a common factor. That common factor is 3 and it can be removed from all 3 terms. This one, x squared, xy and 2x all have an x in common, so we can take that x out and leave the 3 terms exactly in the same order. So that's all there is to it. What we have to remember is every common factor needs to be taken out, all the number common factors and all the unknowns. If they don't divide out exactly, you take the highest common factor, negatives stay with the number that they were always attached to, and as always, factorization is the opposite of expansion.